Hi, I'm Timothy Priscilla, and this morning I wanted to do a word problem for my Math 1325 class that requires u-substitutions for antidifferentiation. Here they give us the projected rate of increase in enrollment at a new college, and they tell us that E of t, the function, is the projected enrollment in t years. If the enrollment is 2,000 now, when t equals 0, find the projected enrollment 63 years from now. Now, what would they be telling us this for? I recall some word problems when we started antidifferentiation. When you're antidifferentiating, you pick up that constant c, and so for these word problems, unless your functions are just going to have a c stuck on there, plus c, they have to give you something that you use to find that constant. So that information there will be used to find c. But before we do that, we need to find E of t, the enrollment function. So this is number 10. Let me write the function down. Well, I dropped the problem, so let me pick it up. And let me sit back down. So E of t is equal to the antiderivative. We're going to antidifferentiate 6,000 times t plus 1 to the negative 3/2 dt. And we have a quantity raised to power, so yes, we are going to have to use a u substitution. Try letting u equal the quantity raised to the power. Oops, just u equals t plus 1. I'm getting ahead of myself there. Then du, the derivative of t plus 1 is a 1 dt. Oh, this is pretty nice. T plus 1, that's going to become a u. You say, but we have that 6,000 there that we didn't pick up. That's fine. Constant factors take care of themselves. All you have to get rid of are the variable factors, and the dt will become a du. So, continuing here, we have that 6,000. T plus 1 becomes the u to the negative 3/2. And what else do we have here? We have the du. So, that's 6,000, u, add 1, negative 3/2 plus 1, that's a negative 1/2, divide by negative 1/2, plus my constant c, and multiply above and below by 2. That'll then give us, well, the 2's will cancel, so that's a 12,000 divided by negative 1. That's a negative 12,000, u to the negative 1/2 plus c. And I'd get that back in terms of t. So here's my E of t. Negative 12,000, replace u with t plus 1 to the negative 1/2 plus c. So there's the enrollment function. There's the enrollment function. Let's suppose you're in charge of recruitment at this new college, and you go tell your boss, well, here's the enrollment in t years' time. Well, that plus c may be a plus 1 million. It may be a plus 1. Who knows? I think you're going to have trouble. Okay, if you go tell your boss, that's going to be the enrollment. So, with that c stuck on there, that's where this information becomes important. If enrollment is 2,000 right now, that means that t is 0. Then the college is just opened and no time has passed. So, the enrollment is 2,000 when t equals 0. So plug in 2,000, take the 2,000, plug it in for the enrollment, take the 0, plug it in for t. So we have 2,000 equals negative 12,000 times 0 plus 1 to the negative 1/2 plus my constant c. So 1 to any power is 1. 1 times negative 12,000 is negative 12,000. So we have 2,000 equals negative 12,000 plus c. So what is my constant of integration equal? My constant of integration is equal to 14,000. So now I know what my enrollment function is. My enrollment function is, let's see, where is it? E of t is equal to negative 12,000 times t plus 1 to the negative 1/2 plus 14,000. So now I have my enrollment function. Let's look back at the problem. They're not asking just for us to give the function itself. They're asking for the projected enrollment 63 years from now. So how do we answer that? What are we going to have to do? Plug in 63. So t equals 63. E of 63 is equal to negative 12,000 times 63 plus 1 to the negative 1/2 plus 14,000. You may want to use your calculator on this. That's 64. The square root of 64 is an 8. So that's a negative 12,000 divided by 8 plus 14,000. Punching that into your calculator or else doing it in your head the way I'm evaluating that to the negative 1/2 the way I did. Either way, we're going to get an enrollment of 12,500 in 63 years time. So this answer here, 12,500. Oh, this was number 10 for my current students. And there's the function that we were anti-differentiating. We let u equal the quantity raised to the power. Once we did that, it fell out very quickly. We had to use the initial conditions to find our c value. And then, once we knew the function, we plugged in 63 and punched it into our calculator. I have one more I want to do if I have time. Here it is. There it is. The rate of expenditure of a particular machine is given by m prime of x equals 9x times the square root of x squared plus 5, where x is time measured in years. Maintenance costs through the second year are $78. Find the total maintenance function. What are we going to use that information for? That part right there. They give us one specific point in time. We're going to use it to find c. But before we find c, we have to anti-differentiate. So we're going to anti-differentiate. I guess I'll call this. Let me move down. I'll call this m for maintenance. They give us the rate of change of the maintenance function. There's the rate of change of the maintenance function. And that's what we have to anti-differentiate. The first thing I'll do is rewrite that radical using a square root and then what do you think I'm going to let u equal? The x squared plus 5, I agree, the quantity raised to the power. Then du is equal to 2x times dx. Oh, let's see. The 9, we don't have to worry about constant factors, but we have to get rid of the x dx. What do we got here that we don't have up here? That 2. Multiply both sides by 1/2 to get 1/2 du is equal to x dx. So, continuing on, we have m equals, we have that 9, the x dx, that's going to become a 1/2 and a du. The x squared plus 5, that's going to become just the u to the 1/2. Anti-differentiating, this will fall out pretty quickly. We have a 1/2, no, a 1/2 times 9, that becomes a 9/2. Add 1, 1/2 plus 1 is 3/2, divide by 3/2 plus c. And 2 times 3/2, that'll just give us a 9 u to the 3/2 over 3 plus c. And 9 divided by 3, this is reducing very nicely just to 3 u to the 3/2, get u back in terms of x. So that's x squared plus 5 to the 3/2 plus my constant c. There's my maintenance function. 9 divided by 3 gave me the 3 u to the 3/2, or replace u with x squared plus 5. And now we need to find out what that constant is. They told us that maintenance costs through the second year are $78. So the maintenance costs are $78 when x is equal to 2, the second year. So we have 78 equals 3 times, plug in the 2, and let's see, either doing this with your calculator or doing it in your head, that's a 9. The square root of 9 is 3. 3 cubed is 27. So we have a 27 times 3, and subtracting that from 78, we get the constant is equal to -3. So what should this c be for my final answer? To find the total maintenance function, we have a 3 times x squared plus 5 to the 3/2. Replace the constant c with the -3. For my total maintenance function. This problem didn't seem that long. I guess I was writing big. I anti-differentiated the derivative. I used a u-substitution, and it simplified pretty nicely right there. Then I had to plug in the initial conditions they gave me in order for me to determine the constant of integration, which turned out to be a -3. Okay, hopefully these 2 examples have worked to help you get your homework done. So enjoy the rest of your day. I'm taking a break. Bye-bye.